This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on trig equations of the quadratic type. So we're going to look at sine, cosine, tangent, squared, etc. to make sense of what we're looking at. Let's take a look at what we have here. Our first example is that sine squared theta is equal to 3/4. And we're looking for theta to be between 0 and 2 pi. So we're going to go ahead and take the square root of both sides. So the square root of sine squared theta will be the square root of 3/4. Now when you do this, remember you've got to play with a plus or minus. The reality is the square root of sine squared theta is the absolute value of sine theta. If that's the case, our next line will be sine of theta is plus or minus the square root of 3 over the square root of 4, which is just 2. So now we have two cases we have to work with. We have sine of theta is root 3 over 2. We have sine of theta is negative root 3 over 2. And we're going to wind up with a total of 4 solutions by the time we're done with the problem. So the reference angles are the same in each case. Sine of pi over 3 is root 3 over 2. So the reference angle here in the first example is pi over 3 for sure. And then we say, where is sine positive? Sine is positive in quadrant 1 and quadrant 2. So we're going to look for a quadrant 1 and a quadrant 2 solution to this. The quadrant 1 solution will just be the reference angle, will be pi over 3. But what about our quadrant 2 solution? So we're not quite at pi. Our quadrant 2 solution would be pi minus pi over 3, which of course will give us 2 pi over 3. So this takes care of our first case, our two solutions being pi over 3 and 2 pi over 3. For our second case, where sine of theta is negative root 3 over 2, the reference angle is the same. It's still pi over 3. So my reference angle is pi over 3, but now where is sine negative? Sine is negative in quadrant 3 and quadrant 4. So we're going to look for solutions in each of those quadrants. So in quadrant 3 it will be pi plus the reference angle. So in quadrant 3 it'll be pi plus pi over 3, which of course is 4 pi over 3. And in quadrant 4 what do we have? It's 2 pi minus the reference angle. Theta is 2 pi minus pi over 3, which will be 5 pi over 3. So we have a total of 4 solutions to this problem. Let's go ahead and write those solutions in set form. Solution is pi over 3, 2 pi over 3 from our first case, and then 4 pi over 3, 5 pi over 3 for our second case. Those are all solutions to our original question. Our original question was sine squared theta equals 3/4, where theta is between 0 and 2 pi. So 4 solutions to that question is what we wound up getting. All right, let's see what we have next. So our next example is 2 sine theta times cos theta equals cos theta. Now, this doesn't really feel quadratic in form, but we are multiplying two functions. Sine theta is multiplying cos theta. So I suggest you subtract cos theta from both sides first, because now we have a situation that equals 0, and we can use our factoring property. Factoring out the cos theta times 2 sine theta minus 1, when you divide out the cos theta, equals 0. So again, two cases, just like the first example. Cos theta is 0, or 2 sine theta minus 1 equals 0. So what's going to happen here? Well, when is cosine 0? Think about when is the x value 0 in the unit circle. Certainly at pi over 2, 90 degrees, and the other case is when theta is 3 pi over 2. So we get 2 solutions for that case. Now, where 2 sine theta minus 1 is 0, adding 1 to both sides, 2 sine theta is 1 and sine of theta is 1/2. Well, reference angle is pi over 6. Sine of pi over 6 is 1/2. That's one we're supposed to know. Where is sine positive? Which quadrants is sine positive? Sine is positive in quadrant 1 and quadrant 2. So we get the solution for quadrant 1. That is simply going to be the reference angle. The quadrant 2 one we have to visualize a little bit, so we're not going to quite get all the way to pi. So our quadrant 1 solution again is theta is pi over 6. What about our quadrant 2 solution? What's that going to be? well, not quite pi, back up from pi. So theta is going to be pi minus pi over 6, which will be 5 pi over 6. So again, we have 4 solutions, pi over 2 and 3 pi over 2 for our first case, pi over 6, 5 pi over 6 for our second case. So you wind up with 4 solutions for this quadratic type trigonometric equation. So 4 solutions for that one too. All right. Well, let's see what is the next equation that we're going to work with. 2 tan squared theta, well, that certainly looks quadratic. Minus tan theta minus 3 equals 0. Well, something is multiplying, tan times tan, so that feels quadratic. As usual, we want theta to be between 0 and 2 pi. Let's go ahead and introduce a new variable. So rather than trying to factor with tan theta, let me go ahead and plug in a new variable. Let's let z equal tan theta. So if that's the case, the original equation becomes 2z squared minus z minus 3 equals 0. And of course, we've got a factor. You could use the quadratic formula if you'd prefer, but I think factoring here is pretty easy. So here's the factor box I like. I want 2z squared in the first slot. I want negative 3 in the upper right slot, and they've got a somehow total negative z. So with the 2z squared here, the only way to make 2z squared is 2z times 1z. Here's the negative 3 in the upper right corner, and there's the negative z in the middle. So indeed, 2z times z is 2z squared. Now how do you make negative 3? Well, you can see I'm choosing to go with negative 3 times positive 1. Does that work? Well, let's take a look. Negative 3 times z is negative 3z. 2z times 1 is positive 2z. Negative 3z plus 2z is negative z. So I've successfully factored it. Z plus 1 is one factor. 2z minus 3 is the other factor. Good idea to review factoring. That's very helpful for these kind of problems and many others. So we want z plus 1 times 2z minus 3 to equal 0. Again, 2 cases. First case, z plus 1 is 0. Second case, 2z minus 3 is 0. So solving those things, we of course get z is negative 1. Adding 3 to both sides, 2z is 3, and z is 3/2. But what was z? Z was tangent theta. So let's rewrite this as tangent theta equals negative 1, or tangent theta equals 3/2. Now, the tangent theta equals negative 1, we can think of our reference angle. Tangent of pi over 4 is 1, ignoring the sine. The reference angle is pi over 4. Now, where is tangent negative? In quadrant 2 and quadrant 4. So I need a quadrant 2 angle and I need a quadrant 4 angle for me to solve that first case. So let's go ahead and find the quadrant 2 and quadrant 4 angle with the reference angle of pi over 2. In quadrant 2, back up from pi over 4. So the quadrant 2 angle will be pi minus pi over 4, which of course is 3 pi over 4. And then how about the quadrant 4 angle? What will that be? We're backing up pi over 4 from 2 pi. So in the case of quadrant 4, theta is going to be what? It's going to be 2 pi minus pi over 4, which will be 7 pi over 4. So I have those two cases. Now, this case, reference angle, tan of theta is 3/2. The reference angle is just the inverse tangent, the arc tangent of 3/2. That's what it is. Where is tangent positive? In quadrant 1 and quadrant 3. So we'll go ahead and write that down here, remembering where tangent is positive. The quadrant 1 angle is the reference angle. All reference angles are quadrant 1 angles. So the quadrant 1 angle is just the arc tangent of 3/2. Now let's think about the quadrant 3 angle. We go pi and then we have to add the reference angle. So it would be pi plus the arc tangent of 3/2. Sorry that plus isn't terribly clear on the writing here. So we have 4 angles that we're going to use that'll solve our original equation. From our first case, we have 3 pi over 4 and 7 pi over 4. And for our second case, we have arctangent of 3/2 in the first quadrant, and in the third quadrant, pi plus the arctangent of 3/2. And that will conclude this lesson.